let's say Alaska, and it's December, what's the probability that I'm going to go to the beach? Or let's say Seattle. Seattle in December. Is it likely that I'm going to go to the beach? No, because for me to even consider going to the beach, it has to be a sunny day. Okay, and we know that Seattle in December is generally not sunny. Okay, so we need to know what the weather is going to look like before we can even answer these questions that don't consider the weather. Okay, but if we know the weather, then we can talk about going to the beach and watching TV. Is that okay? Okay. What if I tell you that the forecast says the probability of sunny, they say that it's always the probability of rain, but we'll say the probability that it's a sunny day according to the weatherman, let's say, is 80%. We live in Southern California, so they tell us that the probability that it's going to be a sunny day tomorrow is 80%. Okay? Then I ask, what is the probability? So according to the forecast, this is what we have. So then I can say, what is the probability that it's sunny and I go to the beach? What would you say? Yes, we would do some multiplication here, okay? So for it to be sunny and I go to the beach, two things have to happen, okay? First, it has to be sunny. Okay, and the probability of that happening is 0.80, okay? And then I must draw the beach card. So I multiply that by 1/3, and I get, was that 20.2667? And so, if the forecast says 80% chance that it's sunny tomorrow, then the probability that I end up going to the beach and on a sunny day is 0.2667. Is that okay? All right. What if I say, what's the probability it is not sunny and I watch TV? Okay, so first it has to be not sunny. And what's the probability that it's not sunny? 0.2. And we got 0.2 because not sunny is the complement of sunny. So I do 1 minus 0.8. And then I multiply the probability of watching TV, basically given that it's not sunny, which is 0.5. And so here I get 110. Okay. And then, what if I ask, what's the probability that I just end up watching TV? Okay, so for me to end up watching TV, there's two possible ways. It could be a sunny day, and I just decide to watch TV. Okay, it could also be a cloudy day, and I decide to watch TV. Okay, so there's two ways. It could be sunny, so that would be 0.8 times the probability of watching TV, given that it's sunny. Okay, so I multiply that by 1/3. Plus, it could be not sunny, times the probability that I watch TV, given it's not sunny. So I multiply that by 0.5. So here I would get the overall probability will be 0.2667 plus 0.1, and I get 0.3667. Are all of these examples okay? Okay, good. All right, so let's see. So let me just write the probability of A and B can be calculated as the probability of A times the probability of B given A. So depending on the pieces of information you have, maybe you are going for this, and you'd find it by multiplying this times this. Okay. Conversely, if let's say you have this information and you have this information and you don't have this information, okay? Then you can also, just from rearranging, we can also get that the probability of B given A is equal to the probability of A and B divided by the probability of A. Okay. So depending on what pieces of information you have, maybe you need to solve for this, maybe you need to solve for this. Okay. These labels, A and B, are arbitrary, so you can always just switch letters around as well. And the probability of A given B is equal to the probability of A and B divided by the probability of B. Okay. Well, I guess technically it would be B and A, but rule is the probability of A and B is exactly the same as the probability of B and A. There's no difference there. Okay. Maybe mentally we think that A has to come before B or something like that. That's not necessarily the case. Okay. So this is what we have. Okay. So we can also illustrate we can illustrate probability problems using what we call a probability tree. So let's say we have the same silly example where we decide what to do by drawing pieces of paper. I'm sure I don't think very many people do this, but I'm sure somebody does. And there's probably an app that does this for you, where you just say, what should I do today? And you can click the button and it spits something out, right? Doesn't, well, like Yelp, you say like, where should I eat? You can hit the roulette button or whatever it is, and it picks a location. I don't know if it's truly random or not, or if it's rigged. Who knows? Doesn't matter. Okay, so we can illustrate this using a probability tree. Okay, and so first, we have to look at our weather. It could be sunny or it could be not sunny. And then if it's sunny, we have three possible things. We could go to the beach, we can go on a hike, or we can watch TV. And if it's not sunny, maybe we go watch TV, or we go to the movies. And in this case, we said the probability of it being sunny was 0.8, and the probability of it being not sunny is 0.2. And then on each of these branches, we put the given probabilities, or the conditional probabilities. So if it's sunny, we end up going 1/3, 1/3, 1/3 for each of these branches here. And over here we have 1/2, 1/2, or 0.5 and 0.5. So to answer our questions of what's the probability that it's not sunny and we watch TV, we would just go down the line and we would do 0.2 times 1/2. And we would say this is 0.10. That's the probability that tomorrow ends up being not sunny and I watch TV. Is that okay? All right, so let's try an example here for you guys to do. All right, can I erase this actually? Okay, let's say you are trying to go to travel somewhere, I don't know. You're flying to New York, okay? And you're going to have a, you make a transfer in Chicago. And they say, okay, somehow you know this information, okay? And they say if there is a storm, the probability that your flight from Chicago, that the flight is delayed, or not on time, so I guess canceled. Delayed, canceled, whatever. Delayed, not on time is 60%. Okay. I guess that would be actually terrible for an airline, but whatever. But if there is no storm, probability that the flight is delayed is only 5%, 0.05. Okay. So you check the forecast. Forecast says probability of a storm is 20%. Let me just think about that. Okay. 0.20. Okay, so I will ask a few questions. Draw a probability tree here. And we'll say, what is the probability that there's a storm and your flight is on time? Okay. What is the overall probability? What is the probability that you're just on time? On-time flight or non-delayed flight, regardless of the weather, or not regardless, but just overall. Okay, those will be my 2 questions. So go ahead and take a few minutes to solve this. Sphere. How are we doing? Another minute, or are we good? Okay, thank you for your response. Well, then we shall go. All right, so we will talk, first we look at the weather, okay? We either have a storm or no storm. Okay, and then either our flight is on time or it's delayed or not on time. So we're simplifying our world into these outcomes. Okay, so we say the probability of a storm is 0.2. Probability of no storm would then be 0.8. if there is a storm, what's the probability that our flight is delayed? 0.6, which means the probability that it's on time is 0.4, 1 minus 0.6. And over here, if there's no storm, then the probability that it's delayed drops down to 0.05. And this is 0.95. Okay, so the first question says, what's the probability that there is a storm and the flight is on time? Okay, so in this case, I just go down the line and I do 0.2 times 0.4, and I get 0.08. Okay. And so that would be the probability of storm and on time is equal to the probability of a storm times the probability of on time given storm. And we get 0.08. Okay. And then over here, what's the probability of an on-time flight? Probability of on time? Well, that could happen if there's a storm, I can still be on time. Or if there's no storm, I can still also be on time. And so I would have 0.2 times 0.4, which we found above to be 0.08. And plus the probability of no storm and being on time, which gives me 0.76. And so that adds up to 0.84. Okay. This one, again, is probability of storm and on time. And this would be probability of no storm and being on time. And when you combine those two together, then that ends up being the overall probability of being on time. Is that okay? Okay, let me ask you another question. Alright, so let's say you are now the friend picking you up. Okay, you get to the airport, and on the screen it says the flight has been delayed. Okay? So you now ask, so if the flight has been delayed, what is the probability that there was a storm? Okay. So this time, yeah, now we know the flight's been delayed, and you go, oh, I wonder if there was a storm in Chicago or whatever. That's what we're asking. So. Okay, I just walked around, and it seems a lot of you are stuck. Okay, and I guess what? Maybe I just want to make sure. Did the last problem go okay? Yeah.
I think
Okay.
it's because it's switched.
It is switched, and it is trickier. That's true. Okay. All right. Well, again, if you are stuck, or if you're having problems with anything that I'm explaining, don't hesitate to ask questions. Okay. I'd hate for me to just keep thinking everyone's okay, and then find out that we're not okay. All right. So in this case, we're saying if the flight has been delayed, what's the probability that there was a storm? Okay. How can I write this in terms of, symbolically? We're using a probability statement. What am I going for? I'm asking, what piece of information am I asking for, and what is given to me? Yes?
So the probability of a storm given delay.
Yeah, so we're looking for probability of a storm given a delay. Is that okay? All right. Okay. Do we remember how to find this? So I might have written something like probability of A given B is equal to what? Probability of A and B divided by probability of B. Okay, so over here, I'm going to have probability of storm and delay divided by the probability of delay. Going from here to here. Good? No good. Good. Okay. All right. Can we get, huh?
You erased it.
Oh, I erased. Well, this thing was earlier. This should already be in your notes. Probability of A given B is equal to the probability of A and B divided by the probability of B. This should be in your notes already, I think. Okay. So all I'm doing is I'm just saying, so we read the problem and we're asking what's the probability of a storm given a delay, and I'm using my definition of this thing to say, okay, well then that means I'm going for this. All right. Okay. So do we know how to get the probability of a storm and delay? What's the probability of a storm and delay? How do I get that? What numbers do I multiply? 0.2 times 0.6. So I go down this line and I would get 12%, 0.12. So storm and delay is 0.12. Yes? Yes. Okay. All right. And then the other part, probability of a delay. What do I have to do there? So I have to, there's two numbers I have to calculate, okay? So in the previous problem, you had to find what's the overall total probability of being on time. Now we're asking what's the total probability of being delayed. So there could be a storm and I'm delayed, or there could be no storm and yet I still end up being delayed. Okay. So we have a question?
Would that be 0.8 times 0.05?
Yes, so probability of no storm and being still delayed would be 0.8 times 0.05. So this is 0.04. And so the total probability of being delayed would be 0.12 plus 0.04. And so the total probability that that the flight is delayed is 0.16. Is that okay? Yeah. Good? Alright, so now, what's the probability that there was a storm given a delay? So for that, I would do probability of storm given a delay is going to be 0.12 divided by 0.16, and I get 0.75. A common mistake is that students kind of mix up their numbers and they end up doing 0.16 divided by 0.12. What would happen if you did 0.16 divided by 0.12? You'd get 1.333, okay? You'd get a number greater than 1, okay? Anytime you get a probability greater than 1, you know you messed something up, okay? So, if you get a number bigger than 1, you messed something up, so just check all of your numbers. Is this okay? If you were to see a question like this on the quiz next week, would we be okay? Yes?
Is that a hint?
Is that a hint? Yes. You will see a question kind of like this, okay? It's not going to be storms and delays, it's going to be something else, all right? You do have an exercise in your homework similar, but different, okay? So, no. Okay, well, why don't we take a 10-minute break?